as the Win32 API. This has been around since 1993, which is 9 years older than me. But it's still the same API. And why do we need this? Let me tell you what an API is first of all. API stands for Application Programming Interface, and it's just a connection between two softwares or more. So let's say that you have two states in your country and you want to travel from one state to the another by road. In the same manner, this lets our application communicate with the Windows operating system. Now, why do we want to communicate with the Windows operating system? Win32 API is the bridge that I talked about. It can do a lot of things like networking, Win input subsystem, file systems, and also window management. So there are some certain steps that you need to take into account for creating a window in Windows operating system. But I will also tell you a little bit about the naming conventions and the different data types and some terminologies to help you better understand this. So as I told you, this API has been going around for 30 years. The byproduct is the naming conventions because it has to support a wide variety of softwares, a wide variety of operating systems. And you can visit here and you can see some of the suffixes and prefixes and what they mean. And it's really easy to understand. Now about the data types, they're just type defs. Now let's open our whiteboard because I want to explain some things to you before getting into the window creation thing. This is Win32 API, and two things that we must discuss is handle and module. So what a handle is just a reference to a resource. So it can be a void pointer, it can be anything. It's just a reference to a resource. And handles, they are pooled in the memory, and I guess only a specific amount of numbers of them are allowed. So you request them from the memory, and when you release them, they're given back to the pool. So if we just open our task manager and let's see our processes, you can see how many handles are there right now. This is really cool. Now what a module is. A module is code or resources. I'm so slow at typing. Code or resources that are loaded in the memory and can be executed or are maybe executing already. Okay, so what kind of things are here? .exe or .dll. So how does a window creation works? Firstly, you have to get the handle to the current context, to the current instance. Instance is just this module loaded in the memory. So let's, in our case, it's our testgame.exe, and that is the instance, and we need a handle to that to create our window. But before creating our window, we have to tell the Windows operating system that we request some window from you, and we need to tell you that this is the size of the window, so just make some space for me. And that's what register class does. We just register a window class there. Then we create the window class, and we also retrieve the handle to that window because it's gonna be used later. Like it's just like a pointer reference, okay? It's way much more than that, but that's like the vague outlook to this. Then we just have to show this window. And this is all there is to window creation. But we also want to handle events. I will tell you a bit more in detail about how events work in the Windows operating system. So for every physical device that you connect, there are like software drivers, device drivers. You install them, or in Windows 10 it gets auto detected and gets downloaded and installed. Now these device drivers are responsible for communicating with your physical devices and translating those inputs into something that window can understand. So it sends those input to input subsystem of the Windows operating system. Now the input subsystem only gives you like the info that is needed for you in the input message queue. Now it translates those inputs into a message, and a message contains like what kind of input it was and what are the other properties related to it. And then what happens is this message queue sends these messages to all the modules that are currently loaded, and it eventually gets sent to our module, which is our testgame.exe. And now we have to handle this message in our application. So what a window requires us to do is have this window procedure callback. This is where we will do a lot of things. I'll talk about window procedure later. First, let's talk about how to handle this message. So this message comes to our module. We have two options to deal with this: get message and peek message. Now what get message does is it takes the message from this queue and it processes it, and then it removes the message from this queue. Now it always returns 0 when a message is processed, I mean non-zero value, which is true, and it returns false when it encounters a VM quit message, which stands for what it means. It just means when you quit the application. So that's what get message do, and it also waits until a message comes. So it's just gonna wait until a message arrives, and this is like really usable for a main message loop. What peek message does is it just retrieves the message from the message input queue, but it does not remove it. It's up to us to remove it or not to remove it, and it does not wait for the message to occur. If there is no message, it will just come back, and we have to manually write to return false if we quit. Now after we get these messages, we have to translate them into characters. What I mean by that is when you are pressing keys, it comes as virtual keys to the window, and then you have to translate it into characters which you can code upon. Like you change this into, then you can change the character into the ASCII code, which is like 65 for A and so on, and that's what we want to do. After translating, we dispatch the message, and what dispatch does is it calls our window procedure, which was the callback, and here we can send events and do a lot of other things. So let's dive into our code and let's get started with all of this. So this is how we left it. We first need to remove these test events because now we're going to do real events. So haha, this is our Windows window class, and I'm just going to copy and paste the code. So as I told you, not much here, just the process messages function, which is new. So in here, this is our window procedure, and it needs to be written exactly like this. Now this callback is just a macro for this std call. Now std call is just a calling convention, and it makes sure that the rules of calling a function are followed, like the parameter passing is in the order and the call stack is fine and so many other things. And the L result is just a long pointer, and a long PTR is just a type def for int64. Now we also have this handle, which is to our instance, which I told you about. We have our handle to our window, and tchar is just a normal character, and this is to store our class name because I don't want to use this many times. I just want to have this because this thing is getting used multiple times. Let's go to our source file now. Now let's copy and paste everything here. So we were here last time, which is Windows window. Now here we are saying initialize the handle with get module handle null pointer. Now get module handle just returns the handle of the module that's loaded in the memory, which belongs to the current process. When we pass null pointer to it, it just means the current module, and the current module is going to be the text game.exe. It expects a null terminated string here. Then we initialize our window with the window properties, and here you can see that we have this Win class structure which contains all the different info for our class. So we have our class name, we tell which instance it belongs to, and then we have the icon, which we just load the default application icon, and for the cursor we also just load the default arrow, and then we tell what our callback for handling messages is going to be like. So this is our function there, and the style, it's really important. So this is a default style in which you can resize the window, close the window, and it just handles everything using this default window procedure. Now what we do is call adjust window rect. This is done to make sure that this rect gets modified and it's not the whole window size. Like here, we say that do not take this whole size. Wow. I'm really good at drawing. So we say this is the whole size. Will it make it align? Nice. We don't want this whole size. We just want this size, because that's the title bar. We exclude the title bar. We just want this size. So that's what is happening there. Then we register this class, and if it fails to register, just return the error. And then we create the window and we store our handle. Here it has like different parameters, like the class name, the title the window is gonna have, the style, the area, the like the width and height, and many other things. And then we just show the window. All right, now the next thing is on update. So we say if process message returns false, we just return from here. Now what this process messages do, it takes a message from our Windows input message queue, and what is here is like which handle, what's the handle of the window that you want it from, and then here you have like the minimum event that you can support and the maximum event that you can support. Now if you will look at events, they're just like defines for these hexadecimal values. So if you say that I don't want any event to capture which is lower than this VM close, then you can just put VM close here, and now you will completely just avoid all of the events that have a lower priority than this. So, and same with the maximum. If some event has maximum priority, then what you want, you can just ignore it. Now this here is like what to do with this message once it's retrieved. Do you want to remove it or do you not want to remove it? Which is no remove. We want to remove it, of course. And if the message is VM quit, that means quit the application, we just return false. Else we translate that message. I already told you what this does, and then we dispatch the message, which then comes here. Now this is our handle to the window. This is the message. This contains the type of the event. We will using switch statement here to like handle all the different types of event. Then this is wparam, and if you look into it, it's just a uint pointer, which is unsigned 64-bit integer. And if you will look to lparam, it's a long pointer which is a signed 64-bit integer. Now the value of wparam and lparam are different depending on what the message is. So let's take into consideration our key down message, and let's go to the Microsoft documentation. Now you see here that wparam contains the virtual key code of the non-system key, and the lparam and the different bits of it contain some different information. So the 0 to 15 bits contain the repeat count, and we have the scan code and everything else. So what we are doing here is checking if the key is not repeating. we only want to send a key down event when a key is not repeating. The high word returns the high 16 bits of this, and then we mask that with a repeat which expands to this. And if this is not equal to kf repeat, that means it is not a repeating operation, and we can send our event. Now the w param contains the key code, and that's why I just convert into int and send our key event. This is all giving an error right now because I've also updated the name of the macros. We will do this later. Now key up, it's really simple. Just convert this and send the event. So next is our mouse moved event, and these are the two macros in this header file. And if you go here, it just returns the low and high, like the low 16 bits and the high 16 bits of this 32-bit value, because it converts it into a 32-bit. If you can see here, it converts it to a 32-bit, and then it converts it back into an int. And for the left button, right button, and middle button down, we just use this ternary operator and send the event. So we say if the message is right button down, it's 3. If the message is not right button down, let's see if it's middle button down, then it's 2. And if it's not middle button down, then it should be the left button down, which is 1. And then we send the mouse button down event. And here is the same thing, but it's just a mouse button up event. Then we have the VM size, which is an event that occurs when our window gets resized. So the width just gets the 16 lower bits and the height just the 16 upper bits. And then we send that event. Paint is when you have to refill the whole area again, like whenever your size changes, then a paint event occurs because you have to paint this screen again. And we're just doing a simple painting operation here. So this is the handle to the device context, and we just begin the paint operation and end the paint operation, and in between this we paint the whole thing. So this is a DC brush, which is like the direct brush. We set its color to 10, 20, 30. It is RGB, and then we fill this rectangle, and then we get the stock brush that is responsible for coloring this whole area with this solid color, and then we convert this into a handle to the brush. Okay, then we just end the painting operation, and this is the VM close operation. This is just window close. Then we have VM destroy, and for every other event that we do not handle, we just run the default procedures, so the minimizing, the maximizing can also handle on itself. Now I've also done some changes to our event system and added the ability to remove listeners. So let's just copy and paste the new code, and I'll explain everything to you. So now we have this listener ID and this listener handles. The listener ID is just like, what's the ID of the current listener? And it gets incremented as you add more listeners to this dispatcher. Now this is a map which has this listener ID, and then it's a pair of type of the event and the iterator that is for this whole vector of functions. So what happens is when you try to add a listener, it just pushbacks as normal, and then you set the handle to this, and then it increments it, and then for this handle, for this handle right there, for this key, this is the value you give. So type is just the type of the event, and here we use std previous to make sure that our iterator is always pointing at the last event. We can have offsets to this as well, but it will result into program errors. But we can just have an offset of 1. That means go to the end and then go a value before that and set our iterator's location to there. But we just want the end location, and then we return the handle. Now when you want to remove the listener, you have to put the handle for that listener. So we have to store this value that this returns now. It earlier used to return nothing, now it returns the handle to the listener that we just added. Now for remove listener, we just give the handle, and then it tries to find if there is any value for this key. If there is, then just get the second part of that value, which is this whole thing. Now tell me the listeners they have based on the type of this thing, of this event, and then erase the listener. From there we get like the list of listeners for this event type, and then we just remove that listener, and then we remove this whole thing from our listener handles. And that's how this works. Send events still work the same way, so there is no need to explain that. And I have decided to change the name of the macros. Like if Windows can do it, like you see these are all macros, like, and they look really pretty. Also, I forgot to tell you one thing. A is for unsigned encoding, W is for Unicode encoding, and so on. So here we are in our event handler. I'm just going to rename all of this. Now you see the different names, and we also have the remove window event listener, remove mouse event listener, remove key event listener. And in the logs, I've also changed this. So just let me copy that. So this is how our logs look like now. We have this log engine trace to log for the engine values. And if it's not in the debug mode, then just have nothing for this macro. And if it's not in the debug mode, then the same here, but this is for the game. So if we're in our mini engine build, this will have a definition, else this will have a definition. Now we need to test what we have done in our test game. So let's just open that. So this is our new test game. I have renamed everything. And here you can see that mouse moved event handle. I'm retrieving the handle from the mouse moved event. And when we get into our mouse moved event, there's nothing happening. Just it prints all of the things like mouse moved. But in the on key event, you will see that when we are pressing our spacebar, which has a key code of 32, we are just going to remove our mouse moved event handle just for testing. We also need to change the name of the macro here to log engine trace. And let's just comment this out because I don't want this to be printed every time because it's really cluttering. And we also need to remove this stdc out and switch to our log engine info. And same thing here. Now let's try to run it. You can see our really beautiful window with that 10, 20, 30 RGB color, and it paints itself when it resizes, and it can handle everything. And you can also see all the events happening. So this is get key down, and that's why I have pressed down the S key and I have not released it. And you can see that it's sending a repeat action, and we don't want to send the key down event when it's repeating. And now when I take it up, you can see the key up event, and it's the mouse moved event. Now every time I move my mouse, it gets done, but I can unsubscribe to this by hitting my spacebar. Now when I move my mouse, nothing happens. But when I click, you can see 2 for the middle mouse button, 1 for left, 3 for right. And it's a lot of fun. In the next video, I don't know what we're going to do. Maybe we're going to make a Linux window, or maybe, I don't know. Let's just take this simple and cut this off from here. This is the window close event. Take care, guys. Thank you so much for watching. Hope you had fun.